Hello, my name is Brandon Mittman, and this is my 15112 term project. This project is based on an exhibit created by high school volunteers at the Carnegie Museum of Natural History in the summer of 2012. It is meant to succinctly teach teenagers about some of the issues surrounding forest fragmentation. The game puts the user in a position of a land manager in charge of a forest. The user will be given scenarios in which he has to make choices that will affect the makeup of the forest. The choices will also affect the user's money supply and the populations of the four animals pictured below, which are calculated by models based on scientific research. Cowbirds live in sparse, semi-open areas, so their population is proportional to the edge forest, which is drawn in light green. Flying squirrels and scarlet tanagers prefer mature forests, so their population is proportional to center forest, drawn in darker green. Black bears can live in either part of the forest, but must have a large contiguous area in which to live, so the program uses a modified flood-fill recursive algorithm to count the amount of contiguous forest above 600 acres in size, and the population is proportional to that count. At first, the user is prompted to explore. The cursor turns into a hand when it hovers over a clickable area that will give the user information or definitions. The forest is stored in a 2D list containing a single value for each acre or pixel of forest. For the first turn, the user must build a road connecting two ranger stations at opposite sides of the forest. Using click and drag, the user turns forest pixels into road pixels. Each road pixel drawn decreases the user's money, and the program automatically fills in road in places where the two pixels are touching only at a corner. The program then determines which forest areas are close enough to the road to turn into edge forest. Finally, the program uses a recursive backtracking function to determine whether the two ranger stations are connected. In the second turn, the user can choose to log areas of the forest to gain some money back. Each click clears all the forest within a one row or one column radius. A new edge and each acre cleared gives the user more money. New edge forest area is once again determined, and we can see how the animal populations in forest acreage has changed since the beginning. For the third turn, the user must choose whether to pay $30,000 to fight a forest fire. We will not fight the forest fire because it's more interesting that way. The starting location of the fire is randomly generated, and the fire jumps randomly from adjacent pixel to adjacent pixel for a randomly chosen number of iterations. The range from which the number of iterations is chosen is much smaller if the user decides to fight the fire. Since this is Western Pennsylvania, the final turn prompts the user whether to accept money for a Marcellus Shale gas drill to be built on the forest. We will choose yes by pressing Y, and we now have a gas rig that we must connect to the highway to the west of the forest. Once again, the program uses a backtracking function to ensure that the drill is connected before allowing next turn to be pressed. And that's the end of the game. The score is computed and a high scores list is displayed, and the user can continue to click around, mess around with roads, or restart the game by pressing R.